Hi, today we're looking at GCSE Maths. We got the Pearson Edexcel exam board. This is from June 2022 and we're looking at paper 2 on the foundation level. So that means we can use a calculator for this one, paper 2. So question 1. Write 1476 to the nearest 10. Okay, so nearest 10, so we can think, well, what 10s are either side of it? So if we set that to 0, we would have 1470. If we go to the next 10, will it be 1480? Halfway would be 1475. 1476, well, that's going to sit somewhere in this half. So it's going to go up to 1480. Now you might prefer to just say, well, it's the 10, so I'm looking here. So I look at the digit after and see if it's 5 or more. But I think writing it out like this helps us to kind of make sure we know what would it be if we rounded down, what would it be if we rounded up, and it makes it much easier to know which way to go. Okay, question 2. Write a fraction in the box to make the calculation correct. So 1 minus 3/10 equals, well, you could do this on a calculator if you want to. I think it's much easier to just say, well, 1 is equal to 10/10. So if you take away 3/10, you're left with 7/10. So let's see what that would look like on the calculator. So we would do 1 minus, then press our fraction button. We've got 3 on the top, 10 at the bottom, equals. I've got my calculator set to show the answer as a decimal. We want it as a fraction, so we can press the SD button and we can see it's 7/10. Question 3. Here is a list of numbers. Write down the mode of the numbers. Well, the mode is the number that occurs the most often. We could do a little table, but actually we've got 1, 2, 3, 4 3s. We haven't got anything else as many as the 3s. So the mode is 3. So it's not how many times it occurs, but it's which number is there the most. Question 4. Write down a 3-digit number that's a multiple of 5. Okay, so I know any number that ends in 5 is a multiple of 5. They want 3 digits, so I can put 125. Okay. Any 3-digit number that ends in a 0 or a 5 should work as well. Question 5. Write 0.4 as a percentage. Okay, so 0.4, turn it into a percentage, we're multiplying it by 100. So 0.4 times 100, we get 40%. So just show what we've done there. There you go. Question 6. Write the following numbers in order of size. Start with the smallest number. So the smaller numbers are going to be the negative numbers. So we've got these 3 are negative. So the smallest will be the most negative. So minus 11 is the most negative. Then we've got minus 7. Then we're left with minus 2. Now we look at the positive numbers and we just want to go with the smallest. So 3, then 8, and then 10. Question 7. Here is a polygon, A, B, C, D, E, F. Basically it's showing you all the corners of it. And it's on a square grid. Okay. Write down the mathematical name of the polygon. Well, it's got 1, 2, 3, 4, 5, 6 sides. So that is a hexagon. Part B. Which side of the polygon is parallel to side CD? Right, so here's CD, this one. Parallel, so it means it's running in the same direction. So it can't be these, can't be these. So it must be AF. part C, write down a side of the polygon that is perpendicular to the side AF. Here's AF, so perpendicular means it makes a right angle with it. So it's going to be either this one or this one, so you can choose. So we can go with AB or EF. I'm going to put AB. Question 8. Here is a centimetre grid. Write down the coordinates of point A. Right, so we want the x coordinate first, so that's going to be the 3, and then the y coordinate 2. So 3, 2. Part B. On the grid, mark with a cross the point with coordinates -4, 3. Label this point B. Okay, so -4 over here, and then 3. So here's the -4, and here's 3. So mark that with a cross and a B. And then for part C, on the grid, draw the circle with centre 1 - 1 and radius 4 centimetres. Okay, so first of all, centre 1 - 1. So 1 here, -1. So that's going to be our centre. And we want a radius of 4 centimetres. Now remember, they've told us that this is a 4 centimetre grid. So I'm going to need my compass for this. So I'm going to insert the pencil in. If it will go in. Yep. Line up the pencil with the point. There we go. Make sure that that's nice and tight. So we want it to be 4 centimetres because it's a centimetre grid. I know if I use 4 squares, that looks about right. So here's the centre. Put that down. And then we just want to carefully draw our circle. Now you want to make sure that when you're drawing it that you're not moving the compass. It's very easy to make the circle uneven. There you go, that looks pretty good. There's our circle. Question 9. The graph shows information about the number of houses sold by an estate agent in each of 6 months last year. So we can see in January 10 were sold, in February that's probably between this and this, so that would be 22, 24, so that would be 23, and we can carry on. Part A, how many houses were sold by the estate agent in February? Well, that's what we were just looking at. So it's this here, and if we use a ruler to draw a cross, we're right in between these two. Now we've got 1, 2, 3, 4, 5 sections here, but a total of 10. So if we do 10 divided by 5, we'll see that each of those sections are worth 2. So as I said at the start, so that's 22, that'd be 24, 26, 28. We're right in between 22 and 24, so that's going to be 23 houses. Now for part B. For this estate agent, write down the ratio of the number of houses sold in January to the number of houses sold in June. Okay, so January, nice and straightforward, that's 10. So 10, 2, and now June. So up here. So it's going to be this one. So remember we're counting in 2, so 52, 54, so that's going to be 56. So it's going to be 10 to 56. Now they haven't said write it in the simplest form, so I'm just going to leave it like that. Question 10. Sonia wants to book a holiday. The holiday will cost £1,428. Sonia will pay a deposit of £150. She will then pay the rest of the cost in 6 equal monthly payments. How much is each monthly payment? And this is for 3 marks. So we've got 1,428. We want to take off the deposit first of all. So we're left with 1,278. And it's in 6 equal monthly payments, so we're going to divide that by 6. So leave that on the calculator, divide it by 6. £213. Question 11. The diagram shows a triangle ABC. So that's this one up here. And we're told ACD, this line, and BCE, this line, are straight lines. Okay, might seem obvious. Work out the size of the angle marked X. Give a reason for each stage of your working. And we've got 3 marks here. Okay, so first thing I'm going to do is, well, I know that opposite angles have the same value. So if I can find out what this is, I can find out what X is. And also know that the total number of degrees in a triangle, so we can put this here, because they've asked for a reason. So total degrees in a triangle is 180. So if we add these two together, 141. So if we do 180 minus 141, that should give me this angle here. So 180 minus my answer, which was 141, we get 39. So that's this angle. And then the second step, we can say opposite angles are equal. So X equals 39 degrees. So when we say opposite angles, we mean 2 straight lines that are crossing. These opposite angles are equal. So it also means that this angle would be equal to that angle there as well. Question 12. I should point out that most of these questions that have come up, they're all classic questions that you'd expect, so none of these should be a surprise. If you can get used to these, you'll see very, very similar questions, just with different numbers. So here's a number machine, input, so that's whatever number you put into it. You then divide it by 7, add 5, and you get the output. Work out the output when the input is 28. So 28 divided by 7. 28 divided by 7. Now, because it's a number machine, you want to put equals after each step. For this question, it doesn't matter, but it's good practice to do that. So we get 4, then we add 5 to it, which gives an answer of 9. Okay, here's a different number machine. The number machine is not complete. So you've got your input, you add something, multiply it by 11, and get your output. When the input is 8, the output is 154. Complete the number machine. So we start with 8, we add something, multiply by 11, and get 154. So what we can do is we can work backwards. So if we're starting with we're starting at the end, so we're starting with 154. Going backwards, we're going to do the opposite. So we're going to do 154 divided by 11, which gives us 14. Okay, so there's going to be 14 here. So 8 plus something gives us 14. So we can say, well, 14 minus 8 gives us the missing number 6. So I probably shouldn't really have put a question mark in there because they want me to write the answer in. So I'll scribble that out and put my 6 there. Again, if you do make a mistake or want to cross something out, just do it neatly, something like that, make it clear what your answer is. If I'd messed that up completely, well then I'd just put a tidy little arrow, show what my answer is. Question 13. Sophie works in a bed shop. During the last 3 months, she sold 198 beds. 59 beds were sold without a mattress. 45 beds were double beds. 17 of the single beds were sold without a mattress. 67 of the 83 king-size beds were sold with a mattress. Use this information to complete the two-way table. Right, loads of information there. This is a 3-mark question. We just start with the information and see how we can fit it into the table, and then see if we've got any gaps missing that we need to work out. So the first thing they tell us, during the last 3 months, she sold 198 beds. So that's our total. They can go in here. 59 beds were sold without a mattress. So without mattress, total of 59. So that means we can work out this one with mattress. So it's going to be 198 minus 59. So we've got 139. Okay, good. We've got total column. 45 beds were double beds. So that's going to be down here. 17 of the single beds were sold without a mattress. So we're single without a mattress. So that's 17 in there. 67 of the 83 king-size beds. So they're telling us we've got 83 king-size beds, and 67 of them were with a mattress. So that's going to go in here. Right, now we want to look for a row or a column that's only got one number missing. So let's start with this one here. So this is going to be the 83, the total, minus the 67. Which gives us 16. Okay, well, we could work out this total down here. We're going to want to add these two together first. 128. And then we're going to take them away from 198. Which is 70. So I'll just write what we did there. We did 198 minus, but we added these two together first, 45 and 83. So if we've got these two, we can work out the singles with a mattress. So it's going to be 70 minus 17, which is 53. To work out these ones, we're going to have to go across. So we can start with 139, the total, and we're going to subtract the singles plus the king size to leave the doubles. So 53 plus 67 is 120. We want 139 minus that number to give us 19. And now for the last box, you could do the same thing again, but I think it might be a bit shorter if we say, well, let's take the total 45 minus the number with a mattress, the 19s, and that will leave the number without a mattress. So 45 minus a 19 gives 26. Okay, so you might have done it in a slightly different order, but your numbers should be exactly the same. Question 14. The box below contains 3 mathematical symbols. Equals, less than, greater than. From the box, choose a symbol to make each of the following statements correct. Okay, so I'm definitely going to use my calculator for this one. So we've got 5/8 first of all. So if I do 5 divided by 8, or you could do it as a fraction, my calculator is set to show it as a decimal. So I've got 0.625. So if yours came up as a fraction, you could just use the SD button to switch between them. and 2/8. Well, let's work that one out as well. Well, that's 0.25. So this is clearly bigger than that one. So I'm going to do my greater than sign. Now here we've got -2 times -3, which gives me +6, because the minuses cancel. And then over this side we've got -3 plus 9, which is also 6. So we need an equal sign in there. Question 15. The table shows information about the number of social media accounts used by each of 300 students. Okay, so we've got 3 people with 0 accounts, 57 with 1 account, and so on. Work out the total number of social media accounts used by these students. Well, I'm actually going to start at the bottom because I think it makes more sense this way. We've got 81 people with 4 social media accounts. So the total number of social media accounts we're going to have here would be 4 times 81. So 324. So we're going to do the same for each of these. We're just going to multiply them together and get the answer. Now, the one at the top, we've got 3 people with no social media accounts. So we're going to have a total of no accounts there. But I'll work from bottom to top as I've started down there now. So we'd have 225, 2 times 84, 168, and 1 times 57 will just be 57. So if we want the total number of accounts, we're going to add these all up. So 0 plus 57 plus 168 plus 225 plus 324. So we've got 774 social media accounts in total. Part B, and this is for 2 marks. Find the median number of social media accounts used by these students. So the median number means the middle number, but it's by these students. We're interested in how many students have we got. Well, we know we've got 300. So for the median number, we can use this, that we want the n plus 1th divided by 2 to find the median number. So let's say if we've got 300 students, it's going to be 301 divided by 2. Which means the 150.5th student. Okay, so we want to find out what's the middle person and then how many social media accounts do they have. And the way we're going to find the middle person, because that's going to be looking at our frequency here. Now, we can't really find where the 150th person would fit in at the moment. So what we need is a cumulative frequency. So basically what that means is we're starting off with the first group, and by the time we've got to the bottom, we'll have all 301 of them. So we can then find where would the 150.5th person fit. So we've got we've got 3 people in that group. So the cumulative frequency here is going to be 3 plus 57. So we'd have 60 people by here. Then we add on the 84. 144, then add on the 75, 219, and add on the 81. It should take us up to the full 300. Good. So where would the 150.5th person be? Well, he's not going to be in here because this only takes us up to 144 people. So we go to the next one. Well, this has gone beyond 150.5th, so it must be this category here. So our median is 3 social media accounts. It's a fairly simple answer, but not a simple way to get there. Question 16. This is for 3 marks. On a scale drawing, a building has length 12.4 centimetres and width 9.4 centimetres. The real length of the building is 62 metres. Work out in metres the real width of the building. So we'll draw a quick sketch here. The length is 12.4 centimetres and the width is 9.4 centimetres. But what we're told is that this is actually 62 metres in real life. So we want to know what our conversion factor is. So we're going to do 62 and divide that by 12.4. And that gives us a nice round 5. Okay. So now we can use that, multiply by this, to get our new width. So we've got 5 and we want to multiply that by 9.4, which gives us 47. And that is in metres. So I've kind of ignored the fact that we're changing units, because I'm just saying, well, we're going from this number to this number, and we're going to do the same with the width. So it might seem odd, but you're going from centimetres to metres. I've not done any conversions, how many centimetres in a metre. We don't need that in this because we're working with the scale. We're just going with the numbers. If you want, you can convert them all into centimetres. You'll see that you still get the same answer. Question 17. On the grid below, draw the graph of y equals 4 minus x for values of x from -2 to 4. Okay, so we want to have our y values and our x values, and we're going to do it when x is -2 and when x is 4. Now, you could work out all of them, but I know because we've just got x here, we haven't got x squared or anything more complicated, this is going to be a straight line. So I only need to plot 2 points, and then I can use my ruler to join them up. So let's start off with this one. If x is -2, we would have y equals 4 minus -2. Now you might remember that minus and minus makes a plus, but if you want, you can just get your calculator to do that. So 4 minus -2 gives you 6. And over here we're going to have y equals 4 minus 4. Definitely don't need your calculator for this one. That's going to be a 0. So we just got to plot those points now. So when x is -2, y is 6. So -2, go up to 6 here. And when x is 4, y is 0. X is 4, y is 0. Right. So I'll take my ruler. So I know it's a straight line because I've only got x to the power 1. I haven't got any squared or cubed. And that's my line. And that's for 3 marks. You don't have to do these 2 points, but you need to do at least 2 points. If you do more, fine, but I think you're just wasting time. I'd say any 2 points. The advantage of doing the two that are furthest apart is that it's just easier to draw your straight line. If they're very close together, the line can go a little bit crooked. Question 18. This sign was in a doctor's waiting room. 115 appointments were missed last month. These missed appointments were a total of 25.3 hours. Work out the mean length of time for each missed appointment. Give your answer in minutes. Okay, mean, so we take the total, 25.3, divide it by how many appointments we've got. Okay, and we get 0.22. Now that's 0.22 hours. This is a bit you've got to be really careful with, because we then want to convert that into minutes. So give your answer in minutes. Well, 0.22 of an hour, we've got 60 minutes in an hour. So we're going to multiply that by 60, which gives us 13.2 minutes. And that's for 3 marks. Question 19. Nimra buys a 3 kilogram box of sweets for £17.60. She puts the sweets into bags to sell. Each bag contains 150 grams of sweets. Nimra fills as many bags as possible. She will sell each bag for the same price. Nimra wants to make a profit of at least 35%. Assuming she sells all the bags, what is the lowest price Nimra should charge for each bag? So loads of information. It's a 5-mark question, so we're probably going to have to do about 5 steps. So we want to start to convert all of these words into some numbers and symbols and make it a bit easy to see what's going on. So we've got the box in kilograms, but we have bags in grams. So let's convert the kilograms to grams first, so we're working with the same units. So 3 kilograms, we've got 1,000 grams in a kilogram. So 3 times 1,000, we've got 3,000 grams. So how many bags can we make? Well, if we've got 3,000 grams in total, and each bag is going to have 150 grams, we'll do 3,000 divided by 150. So we've got 20 bags. Okay. She wants to make a profit of at least 35%. So let's work out how much money she wants to get in total. So she paid £17.60. She makes a profit of 35%. So we want to add 35% onto this. We want the money she gets to be 35% more. So we're going to do 35 over 100 times this amount. So 35 divided by 100 times £17.60 means we want a profit of £6.16. So we need to add on the original amount she paid for the sweets. Means she needs to get £23.76 from all of her sales. Well, if she's doing 20 bags, we divide that by 20 to get our individual price, which is 1.188. Now, this is money, so we can only have 2 decimal places. She wants to make at least that amount, so we definitely need to round up. So we're going to have £1.19p. If we want to check, we could then multiply £1.19 by 20. Yep, it gives at least this amount, so it gives more. If we only did £1.18 times 20, it's not going to be enough. So this is what we need. And that's a 5 marks. Okay, question 20. Lorena gets a train at the same time each morning to go to work. She gets a train at the same time each evening to come home. The probability tree diagram shows the probabilities of each train arriving late. Complete the probability tree diagram. Okay, so this first bit is a train to work. This is a train home. Okay, and we've got 2 marks for filling in these boxes. We've got 1, 2, 3 that we need to fill in. Okay, so if we just look at the first bit, if there's a probability of 0.13 that it's late, well then not late, it's going to need to be 1 minus 0.13. Because total probabilities need to add up to 1. So 1 minus 0.13, we get 0.87. Now we look at all of these parts of the probability tree separately. So if there's a 0.06 probability that this train is late, then not late is going to be 1 minus 0.06. which is 0.94. And then similarly down here, well in fact it's going to be exactly the same answer because we've got the same number. Okay. And part B, for 2 marks. For a day that Lorena goes to work out the probability that the train to work and the train home will both arrive late. So for a day that Lorena goes to work, we want the train to work and to both are late. So let's see which of the options this is. So we've got late, late. So it's this part that we're looking at. So the probability of it being late on the first bit was 0.13 and being late on the way home 0.06. So we multiply those two together to get, right, so we've got 7.8 times 10 to the minus 3. So we're doing some standard form here as well. So 7.8 times 10 to the minus 3. Now, what we can do is say, well, that's 7.8, 10 to the minus 3. So we want the decimal point to move 3 places to the left. 1, 2, 3. And fill in there. So we can write that in our answer, 0.0078. If you left it in standard form, that would be fine. Or actually, what you could do, if you look at your calculator, if you press the SD button, it does it as a fraction. Probabilities can, unless they specify, you can write it as a percentage, a decimal, a fraction. So you could just write it as 39 over 5,000. Question 21, part A. Simplify x to the power 3 to the power 5. So remember, to the power means you're multiplying it by itself. So what this means is x to the power 3 times 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 x to the power 3. And when you're multiplying the same number or symbol or whatever it is, you can just add the powers. So 3, 6, 9, 12, 15. Just x to the power 15. Now you might know to just multiply them out straight away, but hopefully this is just showing you why it works. And if you want, you could then break it down and say, well, x cubed means x times x times x times x times x times x. So that's from that bit, that's from that bit. And you can see you would end up with 15 x's all multiplied by each other. Part B. Expand and simplify 4x plus 3 plus 7, 4 minus 2x. So when we've got a number next to brackets or a symbol, there's an invisible multiplier in there. So we're saying 4 times x, 4x, plus 4 times 3. You can use your calculator, but I'll go for it straight away. 4 times 3 is 12. 7 times 4. Let's use a calculator as we've got it there. So 28. And then 7 times minus 2x. So it's going to be a minus answer, plus and a minus. So 7 times 2, so it's minus 14x. Now we can put our x's together. So we've got 4x minus 14x. So 4 minus 14, it's going to be minus 10x. And then we've got 12 plus 28 plus 40. And that's absolutely fine, but sometimes it's just tidier to put the positive number first. So we could put 40 minus 10x. Either way is okay. Now for part C. Factorise fully 15x cubed plus 3x squared y. So factorising, we're looking for things that go into both parts of this equation without any remainder. Well, we've got 15 and 3. So if we just look at the numbers, well, 3 goes into both of them. 3 goes into 15, 3 goes into 3. So we can take that outside. So we're going to have some brackets. What about the x's? Well, we've got x cubed here and x squared. So we can take out 2 powers of x squared here. And we can't do anything with the y because we haven't got any y's in here. So now we've got to think, well, what would it look like inside the brackets? So we need to multiply this by something to get us back to here. Well, 3 goes into 15 5 times. So 3 times 5 gives me my 15, great. Now to get x cubed, we need an extra power of x. So when we multiply x squared by x, we get x cubed. Great. Now to get 3x squared, y, well, we've already got 3x squared. We just want the y bit. So that's all we need. And we can put that down on our line here. Okay, question 22. So we've got a picture T, picture S, and our coordinates on our axes here. And they're asking us to describe fully the single transformation that maps shape S onto shape T. So we're going from this one to this one. Okay, transformation. Well, we haven't got any twisting going on or reflections because it's in the same rotation as the one here. So what we have got is we've got a translation here. Translation just means it's moving. Okay. So how much is it moving by? Well, let's see. Let's go across first. So pick a corner. I'm going to pick this corner here. So I want to see, how do I get from this corner to that corner? Well, I'm going to go across 1, 2, 3, 4, 5. But I'm going to the left, so it's -5 this way. And then I'm going up. So 1, 2, 3, 4, 5, 6. And we're going up, so that's +6. So we can describe this with a vector. So we can say it's a translation by the vector. So in other words, it just means move it and move it -5 across. So we put -5 on the top of the vector and then up 6. So this is like your kind of your x coordinates or x movement, and here's your y movement. And that's 2 marks. Question 23. The length of a football pitch is 90 metres, correct to the nearest metre. Complete the error interval for the length of the football pitch. Okay, 90 metres. Error interval. Because it's correct to the nearest metre, it could actually be a little bit smaller or a little bit bigger. Now, for example, if it was 89 metres, well, 89 would be correct to 89. So we're going to need some decimals in here. So if you remember with decimals, we round up when we've got a 5. So if you think, if it was actually 89.5 metres, well, we would, to the nearest metre, that would round up to 90. So actually, the smallest the pitch could be, but still round to 90, is 89.5. Equally, what's the biggest it could be? Well, again, if you think of the 0.5, it could be 90.5. 90.5 would round up to 91. So that's why we've got less than rather than less than and equal to. So if it's less than 90.5, that's fine. So 90.49999 would still round to 90 metres. Down at this end, we have got the less than or equal to, so it could actually be 89.5 metres. Okay? Because it's the nearest metre, it could be smaller, could be bigger. We're just writing down what's the biggest smaller it could be, and what's the smallest bigger than 90 it could be. Question 24. Festival A will be in a rectangular field with an area of 80,000 metres squared. The greatest number of people allowed to attend Festival A is 425. Festival B will be in a rectangular field 700 metres by 2,000 metres. The greatest number of people allowed to attend Festival B is 6,750. The area per person allowed for Festival B is greater than the area per person allowed for Festival A. How much greater? Give your answer correct to the nearest whole number. So, again, loads of writing there. What they want is, what's the area per person for Festival A? What's the area per person for Festival B? What's the difference? Okay, and this is for 4 marks. So, to work it out per person, we've got 80,000, and we just divide it by the number of people. So we've got 80,000 divided by 425, and we get 188.23529. I'll write everything down for now. Now we want to do something similar for Festival B, but for Festival B we haven't got the area. But we do know that it's a rectangle, which is 700 metres by 2,000 metres. So we can work out the area by multiplying them together. Which is 1,400,000 metres squared. So we're going to want to take 1.4 million and divide that by 6,750 people. And we get 207.407407.4. So we just want to take the difference. It's said that the area per person for Festival B is greater. We've got a number that's greater, so that's a nice little check. So we're just 207.4 minus 188.2 and see what we get. So I've got this one here, minus 188.2352941, and we get 19.17. They said give your answer correct to the nearest whole number, 19. So look at the next digit, that's less than 5. So we can just have 19 people. Oh no, it's not 19 people, is it? Sorry, it's the area per person. Oh, let's write that in. So the answer is actually going to be 19. In fact, they've done it for us. They've told us that it's 19 metres squared. And then Callum says 300 centimetres squared is the same as 3 metres squared because there are 100 centimetres in 1 metre, so you divide by 100. Callum's method is wrong. Explain why. Okay, so what we can do is we can show that. So let's think, 300 centimetres squared. Well, let's give an example. We could have 3 centimetres by 100 centimetres. Okay. Now, the area of that is going to be 300 centimetres squared. Now, if we had 3 metres squared, well, that's going to be the same as saying, well, that would be 3 metres by 1 metre. Well, 3 metres is 300 centimetres, and 1 metre is 100 centimetres. So you can see that's 3 metres squared. Well, it's actually going to be 300 times 100 which gives us 30,000 centimetres squared. and these two are not the same. Question 25. The points L, M and N are such that LMN is a straight line. The coordinates of L are -3, 1. The coordinates of M are 4, 9. Given that LM to MN equals 2 to 3, find the coordinates of N. Right. Quite tricky when you get coordinates but don't have any axes or anything to look at. So what we're going to do is we're going to make our own. So let's do a bit of a sketch first of all. The coordinates of L are -3, 1. So I'm just going to pick a point, call that L, and that's -3, 1. The coordinates of M are 4, 9. Well, so 4 is going to be over to the right, and 9 is going to be up. I'm not trying to make this accurate, I just want it to be a sketch to start off. Okay, and we've got a line, and we know that N is on the line as well. So what I'm going to do is draw a line through those 2 points. And we know the ratio L to M to N is 2 to 3. So this line is longer than this line. So let's mark N somewhere up here. And we're trying to find what these coordinates are. Now what we can do is, instead of thinking of it as a straight line, we can think of these as triangles. Okay, because if we can do that, then what we can do is, we're not going to say how long is this diagonal, we're going to say how many across are we going and how many up are we going. And then we can use that and the ratio to then work out how much we need to go across here and how much we need to go up here. So to start off, I'm going to write down the coordinates of this corner. Well, it's going to have the same x coordinates as M, so 4, and the same y coordinate as L, so 1. So if we want to work out the length, how many we're going across, is the difference between -3 and 4. So rather than using a calculator, I'm just going to sort of work it through logically. So we'll be starting at -3, we'll have -2, -1, 0, 1, 2, 3, 4. So we're going 7 across. And then up, we're going from 1 up to 9. So 2, 3, 4, 5, 6, 7, 8, 9. We're going up 8. Okay, so we can use this ratio to work out, well, how far across am I going to have to go here? And then how far up am I going to have to go? So then we can work out what these coordinates are. Right, so we're going across 7 and the ratio is 2 to 3. So if you think 2 to 3, think of it as 3 divided by 2. And if we do that, you see that it's 1.5 times bigger. Okay. So if we do 7 times 1.5, or 1.5 times 7, we get 10.5. So this length along here is 10.5. Now we can do the same for going up. So if this is 8 up, we want 8 times 1.5, which is 12. So we're going up 12 here. So we're going to start with 4, add on 10.5. That gives us the x coordinate. So we can think of this here, that's going to be 14.5. And it's going to have the same y, so that'll be 14.5, 9. Now we want to go up. So we've got that 14.5 is going to stay the same. It's going to be 9, but we're going up 12. So 9 plus 12 is 21. Okay, so it's quite difficult, but it's easier if you can start to draw things down, get some coordinates going. We've got 4 marks there as well, so we're just going to write 14.5 and 21. What's a little bit distracting as well is the fact that we've got a decimal here. We've got We've not got whole numbers. That's fine. Don't let that distract you. And also, because we're getting towards the end of the paper as well, we know that the questions are going to be getting more difficult. So it shouldn't be too much of a surprise as to get something unusual. This is probably more of a sort of a grade 5 question. Question 26, and this is for 3 marks. A new phone costs £679. The value of the phone decreases at a rate of 4% per year. Work out the value of the phone at the end of 3 years. Okay, so it's decreasing at a rate of 4% per year. So at the start it's £679, and that's a full 100%. If it's decreasing by 4%, well, 100 minus 4 is 96%. So to work out this number, we want 679 times 96%. So year 0, and then we'll have year 1, year 2, and year 3. Okay, so if we want the value after the second year, well, it's going to be 679 times 96%, and then times another 96%. Okay, and we're going to do the same again. So for year 3, 679 times 96%, that gets to this value, times another 96%, that gets the value after year 2, and then times another 96%. That's what we want to work out. Well, 96%, if you think that's 96 divided by 100, so we can write that as 0.96. So in other words, what we're doing is sort of the opposite of compound interest. So we're saying 679 times 0.96 times 0.96 times 0.96. Or if it's easier for you to think of it, 679 times 0.96 to the power 3, or cubed. However you want to type it in. So 679 times 0.96 and 96%. We're going to cube that, and we get 600.7357. Because it's money, we're going to want it in pounds and pence, so just 2 decimal places. So we look at the next digit, 5 or more, we round it up, so it's going to be £600 and 74 pence. If it helps, if you're finding this difficult to work out, then work out the value after year 1. Write it down. Then reduce it by another 4%. Work out the value for year 2. You'll see that you get to the same answer. It might take longer, but if it helps you understanding and getting through the concepts, then I'd do that certainly in practice, so that then you feel more comfortable doing a quicker method like this in the exam. Question 27. In Spain, Sam pays €27 for 18 litres of petrol. In Wales, Leo pays £40.80 for 8 gallons of the same type of petrol. We're told that €1 equals 85p in sterling. 4.5 litres equals 1 gallon. Sam thinks that petrol is cheaper in Spain than in Wales. Is Sam correct? So we've got euros, we've got pounds, we've got litres, we've got gallons. We want to get everything into the same units. So what I think we can do is, we know €1, the conversion rate, so I'm going to turn our euros into pounds. And then we're going to have a look at the litres and gallons, which way we convert those. So if we've got €27, let's turn it into pounds. We're going to multiply that by 0.85. Because if you think we get €1 for 85p, So we should have fewer pounds than euros. So 27 times 0.85. Now we're in pounds, so we've got £22.95. Right, now this is the cost for 18 litres. Now what we want to do is see, well, if that's 18 litres, well, maybe why don't we divide it by 18 and we can work out the cost for 1 litre. Okay, so still got that in here, divided by 18, and we get 275. So if we want that in money, we'll round it 1.28p, and that's per litre. Okay, now what we want is we want to do the same thing with our gallons. So in Wales we've got £40.80. And what we can do is say, well, we've got 8 gallons. There's 4.5 litres in a gallon, so 8 times 4.5. That's going to tell us how many litres we've got. So 36 litres, and that's how much it costs. So now we can use these two values to work out the price per litre. So £40.80 divided by 36. And we get 1.133333. In pounds and pence, because we can only have 2 decimal places, we're going to have £1.13p. So we've got Spain and Wales. In Spain, it works out at £1.28 a litre. In Wales, it's £1.13 a litre. It's more expensive in Spain. Sam thinks petrol is cheaper in Spain. Is Sam correct? No. And that's a 4-mark question. Okay, last question. We've got simultaneous equations to finish off. So straightforward, what we've got to do, solve the simultaneous equations. And this is for 3 marks. So I like to number my simultaneous equations 1 and 2. Then I have a look and see, well, what's going to be easier to get rid of. 5x, 6x might be messy, but 2y and 4y. Well, 2y is half of 4y, so I'm going to try and get rid of my y's first of all. So we'll solve for x, and then we can put that back in. So if I had 4y up here, I'd be able to subtract these equations from each other. So what I'm going to do is 2 lots of the first equation. So I'm going to double this one. So 2 lots of 5 is 10, so 10x. 2 times 2y gives me 4y. And 2 times 27, let's use the calculator for that. 54. And I'm going to call that equation 3. Okay, so we've got 4y in both of these equations now. So what I'm going to do is take equation 3 and subtract equation 2. Okay, so I'll write that. So we're going to have 10x plus 4y equals 54. And we're subtracting 6x plus 4y equals 28. So 10 minus 6 is going to be 4x. Plus 4y, they cancel out, so we've got no y's there. And 54 minus 28 is 26. So x is going to be 26 divided by 4. So we've got 6.5. Okay, so now what we want to do with this is to put it back into one of the equations so we can work out what y is. Now normally I'd just substitute it straight into the first equation, but because we've got a 0.5, multiplying it by an odd number, I'm going to still have the 0.5. In fact, what I might do just feels easier. I'm going to substitute it in 3 because then I can multiply it by 10. So I'm going to say substitute x equals 6.5 in, and I'm just going to say 3. So in equation 3. So we're going to have 10 times 6.5 plus 4y equals 54. This is easy to do without a calculator, but you can do it with if you want. Times 10, we're just going to move the decimal point. So we've got 65 plus 4y equals 54. Okay, so now what we want to do is get rid of the 65. So we're going to move it across, and that's going to become a minus 65. So we get 4y equals 54 minus 65 is minus 11. So if that's what 4y is equal to, then 1y is going to be minus 11 divided by 4. And we get minus 2.75. Okay, so we can write, what did we have? We had 6.5 for x and minus 2.75. Now those aren't particularly nice numbers, so you can be thinking, oh, I'm not sure, have I made a mistake? So what you can do if you want to, if you've got time and you've checked everything else, is you can substitute those values back in here. So for example, if we say 5 times 6.5 and then 2 times minus 2.75, let's put that in the calculator and see what we get. So 5, I'll do it in brackets so we can see it all as 1. So 5 times 6.5 plus 2 times minus 2.75. I wouldn't usually do it all in one, but we get 27. And we can do the same sort of thing here. So we can say 6 times 6.5. So we're putting it in the second equation to make sure that works. And then adding 4 times minus 2.75. Good. See, we know we've done it right because it works in both of them. Okay. And that's the end of the paper. So I hope you found it useful. A couple of tricky questions towards the end. Please like the video, subscribe to the channel, add any comments, ask any questions, and I look forward to seeing you again soon. Thank you.